Hello, my name is Chris Wheeler. I'm a first semester PhD student at Kansas Geological Survey and the University of Kansas. I'm a trainee on the Aquatic Intermittency Effects on Microbiomes in Streams, or AIMS project, which is a Track 2 NSF EPSCoR grant. The AIMS project covers multiple sites in 3 different physiographic regions in the US. However, for this poster, I'm focusing on initial data collected at the Konza Prairie Biological Station and Long-Term Ecological Research Site. In general, the study of intermittent streams has become increasingly critical in recent years, as such systems now represent over half the world's flowing water bodies. Additionally, forming a complete and accurate hydrologic model for these systems will help inform how intermittency affects water quality, microbiomes, and lotic ecosystems generally. As such, to contribute to characterization of superficial hydrologic connectivity in these systems using high-resolution spatiotemporal data, 4 sub-watersheds with varying burn frequencies at Konza were instrumented with a set of over 90 stream temperature, intermittency, and conductivity loggers, or stick loggers. A picture of one of these loggers is shown in Figure 6. These loggers are modified Hobo pendant loggers, and they record the presence or absence of water at 15-minute intervals via a measurement of relative conductivity using electrodes. The site was instrumented with stick loggers in May 2021, and data was downloaded from the loggers in September 2021. The 4 watersheds represented burn frequencies of 1, 2, 4, and 20 years, and as such, they are representative of varying land use and vegetation characteristics. The raw conductivity dataset was used to generate a binary dataset of wet and dry measurements. Additional metrics were then calculated from the binary data, including flow duration, the percentage of wet to total measurements for each logger, and the date of first drying for each logger. Additionally, the proportion of total stick loggers showing a wet reading at each time step was calculated, and that is shown in Figure 5. Mapping of duration and drying date, shown in Figures 1 and 2, showed that the subwatersheds at Konza did not dry from top to bottom as might be expected. Instead, loggers in the middle of the watersheds generally tend to have larger durations and later dates of first drying. Furthermore, contrary to hypothesized relationships, comparisons of these metrics to point scale physiographic metrics, namely topographic wetness index and watershed area, show that the metrics do not predict flow duration or drying. These comparisons are shown in Figure 3. Furthermore, Figure 4 shows that the watershed with the longest burn frequency of 20 years, which is N20B, exhibits the lowest median flow duration of all of these watersheds, suggesting a possible land use influence on superficial connectivity patterns. Future work in this area will continue to attempt to parse relationships between stick data and other physiographic and hydrologic metrics. Additionally, I will be incorporating measurements of groundwater dynamics and subsurface connectivity using paired piezometers and stilling wells placed at 6 sites throughout our study area at Konza. Thank you for taking the time to view my poster and to listen to this talk.